Hi, Phil here again. Today I'm going to talk to you about mathematical modelling, all wonderful things about it. So first of all, modelling comes up in the criterion, one of the three criteria, modelling and problem solving. And as I say often, that we just do lots and lots and lots of math problems. We're pretty good at doing that. But what do we do about mathematical modelling, and what does that mean to students, teachers and the syllabus? Well, the syllabus is pretty clear. You can see it written there fairly plainly if you look hard enough, and basically it's talking about a depiction of some sort of a situation using some sort of mathematical terms. What does that mean? Well, the types of models that we might see in a general maths classroom, I've just sort of summarised to four there. These might include drawing graphs, tables, equations, and diagrams. Creating equations, not drawing equations. Pretty clever, hey? They're not the only. That's not the only things that we do in terms of modelling, but certainly they're the ones that are probably most common. So what do graphs look like? We tend to think of graphs as having x and y axes, but they're not the only graphs that kids are exposed to. For example, networks. There's a nice graph, and they can have different types with weights and directions and whatnot on them. And so networks is an example of a graph. I think another type of graph is we see tree diagrams. It's a very clear depiction of some sort of mathematical depiction of some situation, and so we teach kids how to do tree diagrams. We're pretty good at using Cartesian planes, and they're the more traditional types of graphs. What do tables look like? Obviously, they're just the general data tables. One of my favourite ones in Senior Maths B is this sort of table here. When we look at how it's drawn on a graph, it's very different, and I think that it's really good, robust discussions amongst teachers as well of how we would draw a table, how we draw a graph of a table like that. Other tables include things like two-way tables. Equations, we've been doing equations probably since about grade 2 or grade 3, but some of the ones that we'd see in senior maths would be things like wages, parabolas and parametric equations. But and again, how we model them and what we do with them might be unique to each of those subjects. What do diagrams look like? We've got Venn diagrams, I guess, where we're depicting some sort of situation in a mathematical way. And the typical diagram that people use would be drawing the information in some sort of pictorial representation of a situation. Now, all of those I think are really important. There's a huge cognitive step between a student reading a problem and then being able to solve it. And I think that the modelling part of it is a really, really important and an undervalued step in that cognitive process. Now, all of those have a particular purpose, and I think though, if we really look at what's happening when the students are creating those models, you can see here I've listed there for you the reasons what the students would have to do in order to create those models. They really have to get into identify what the assumptions, what the variables are, etc. They need to be able to interpret, clarify. Now look, all of these words that you see there, when you delve down into the caps and maps, you can see some of these words come up time and time again. And I don't think that's by accident that they're in those three criteria, and I don't think it's by accident that we then look at why we would teach modelling in order to achieve teaching those particular objectives. So I think it's important that we do spend some time in classes teaching these particular skills. So let's have a look at an activity of where we might do some modelling. I'm not going to go through all the answers. I think it might be good for you guys to sit down at some stage, and maybe in our tutorial we might actually have a sit down, have a yak about how we might do this. So here's a particular task. How many trees are used to make an edition of a newspaper? I'm not talking about just one edition where I go to the shop and buy one, but say for example here in Queensland the Courier Mail might have 500,000 drop of any particular day. How many trees would be used to make that particular edition of a newspaper? Now, if we go back to that page before, I've just got it up on the screen here, but where, you know, in this particular problem, which of those particular key learning attributes do you see being able to be learned during this? I think it's a magnificent question, and I look at how I would use modelling to do that, and I think that it's a beautiful task. Well, probably best we talk about it if you want to in the tutorial. And I think that you know, how we get the kids to engage in this, I don't think it's a one-on-one type activity, but certainly one that I think is really good for modelling. Have a think about, if you want to stop the video and have a think about how you, all those bullet points there, where do they attach themselves into this particular task. So if I move on to another activity, I think the game Monopoly is pretty popular. It doesn't matter what edition that you use, but the idea behind Monopoly is still the same. Which property provides the best value for money? Now, I think that's a really good question to ask of students about financial literacy, but certainly the game of Monopoly provides those sorts of questions for us. Again, if you want to stop the video now, get out the game of Monopoly and ask yourself that same question. Well, how would I answer that question? Which does provide the best value for money? What do we mean by best value for money? And this question here, I think, is a really good question for Maths A and Maths B kiddies. But again, you look at identifying assumptions, parameters. What are the variables? What do we mean by best value for money? How do I identify what the variables are? A bit of a clue here, number of steps from go, and what the value of that property is might be worth it. Kids would ask the question, do I include railway stations and utilities? But again, they're really good questions that you want to answer. Does that mean that you can buy, if we're looking at this for a financial literacy thing, does that mean that you can go out and buy a railway station? So probably wouldn't include them. So so if we look at, you know, they've just gone through two activities there. Provides us with opportunities to draw tables, graphs, get equations, lines of best fit, you know, all those sorts of things that we might do in order to answer those questions. My note to you as developing teachers, as even experienced teachers should do, make sure that if you ask the kiddies to do a task like that, that you know how to do it yourself first. Please, please, please don't give kids activities that you've never done. You're leaving yourself open for, gee, I don't know. But that doesn't mean to say that you have to be answering all the questions for the kids. I think that when students ask you questions, it's a great opportunity for you to say, oh, what do you think? What do you think? What have you investigated? Is that the only way? You don't have to answer all the questions for them, but I think you should at least know what the answers are. So when we've done this, when we've finished the problem, how do students validate their answers? I think that most kids in the world now, I don't think it's just an Australian thing or something that's here on the Gold Coast, is that students will inherently trust what their calculator says, no matter whether the answer's right or wrong. But if it says the answer's 14, that's the darn answer, and there's nothing you can do to change their mind, or is there? They don't check for errors. So when we're modelling, How do we validate that an answer is in fact 14? Well, show me that the answer is true. Show me the graph, show me the extrapolation of the graph, test that equation, insert data for that variable, and show me that that answer is correct or not. Kids won't do that. That's human nature. I think for young people. Now, when we ask students for validation, I guess part of that process is the answer reasonable? Old men shouldn't live to 155 years old. Can they support their argument with some data? The old strengths and limitation that comes up in our syllabus, and you know, the effect of the assumptions. Well, what happened if the tree wasn't a particular shape? What happens if the tree wasn't that particular whatever? You can then get them to validate their answers by saying, well, my answer is for this one here. However, had it been this particular size or shape or whatever, then they can then start looking at maybe validating their answers. Now, for young people, you know, they just want to solve the problem, but we agree that modelling has got to be a really good way for engaging kids in their learning. They might not, students might not agree with it, but they learn heaps by doing it. And my experience of being in classrooms for a long time now leads me to think that, you know, these robust activities where kids actually start developing the concepts by modelling in this way is something that's really important. So what a challenge for you is, what about if you could find a textbook problem, just typical textbook problem? It might be still they call it a modelling and problem solving question, but how would you adapt it into be a modelling problem? There's a challenge for you. Maybe we could look at this in our tutorial, and what would it look like if we did modify it? Well, thanks for listening, guys. I think we'll catch up again later when I do some more of these videos. Bye for now.